Hello students, today the current electricity lesson. This is the session number 3, and in this session we are going to see the electric cells and batteries, and another very important question, determination of the internal resistance of a cell using the voltmeter. Then the resistors in series and parallel using the battery cells. Electric cells and battery. What are the electric cells? See, an electric cell converts chemical energy into electrical energy. If you see here, using this we connect two negative and positive terminals here, which are made in a zinc electrode for negative terminal and a carbon electrode for a positive terminal. We submerge these terminals in a sulfuric acid based beaker. If you have the sulfuric acid in the beaker and you immerse this carbon and zinc electrodes, the current has to be produced using this. You can see this in the small video. This electrolyte sulfuric acid generates the electricity here. Actually, the electricity is the flow of electrons through a conductive path, which is like a wire. The path is called a circuit. Batteries have three parts. One is anode, another one is cathode, and the electrolyte. Okay, here we use this sulfuric acid as an electrolyte and zinc electrode as a anode and carbon electrode as a cathode. The cathode and anode rays, which are positive and negative sides, are hooked up to an electrical circuit. The chemical reactions in the battery cause an excess of electrons at the anode. So, in batteries, the electrolytes keep the electrons from going straight from the anodes to the cathodes. Here you can see it moves from anodes to cathode, which will light the light bulb. Here I have shown one light bulb for you, and this reaction describes how electrical potential causes electrons to flow through the circuit. The battery puts the right chemicals in the right relationships and then put a wall between them. This is the wall between them. Only when the two sides of batteries are connected by a wire or another conductor can electrons flow. Here I will show another picture. In the batteries we have one anode and one cathode, which is connected by electrolyte, which you can see in a pentorch battery. Even we use a lot of pentorch batteries every day. The cathode have a positive symbol nature and the anode have a negative nature, which we can produce currents even in the lemon also. In most of the past experiments we saw even the potato can produce some sort of charges. Using the last experiments or batteries, let us determine the internal resistance of a cell using the voltmeter. That means The resistance which are produced inside the circuit are measured using the voltmeter. Here you can see a picture of a voltmeter which is connected in a circuit of plus battery with a plus, and another side of a voltmeter, negative side of voltmeter is connected with the resistance and with the negative side of the battery. Here this psi, okay, this symbol is psi, CSI. You can, this is the EMF of the cell, and it is measured by connecting a high resistance voltmeter across it without connecting the external resistance. Okay, we are not connecting the external resistance. Hence, the voltmeter reading gives the EMF of the cell. You can have the in the voltmeter reading will give the EMF of the cell. This cell, remember, we are going to see the EMF of this cell which is connected in the circuit. Now, the external resistance R is included in the circuit, and it is current is established in the circuit. So, the potential difference across R is equal to the potential difference across the cell, which is V. The potential drop across the resistor R is by Ohm's law, that is V is equal to IR. Let's have this as the equation number 1. Now you can see we connected an external resistance which is indicated by the symbol capital R. Already we have an internal resistance, it is small r. Now we connected an external resistance with volt, and it is represented by the symbol capital R. Due to internal resistance small r of the cell, the voltmeter V is less than the EMF of the cell. That means psi, which is V, is less than psi. And it is because certain amount of voltage IR has dropped across the internal resistance R. Okay, some amount of voltage has been dropped across the internal resistance which is small r. Therefore, V is equal to psi minus IR, or IR is equal to psi minus V. Let us take this as equation number 2, and IR divided by capital IR is equal to psi minus V divided by V. And dividing the equation number 1 by equation number 2, we get small r is equal to psi minus V divided by V modulus into R, which is given by the equation number 3. Since psi, V and R are known, internal resistance small r can be determined. We can also find the total current that flows in the circuit. Cells in series. Several cells can be connected to form a battery. In series connection, as we saw in resistors of series connection, conductors of series connection, the negative terminal of one cell is connected to the positive terminal of the second cell. The negative terminal of the second cell is connected to the positive terminal of the third cell, and so on. The free positive terminal of the first cell and the free negative terminal of the last cell become the terminals of the battery. Here I can show you the serial arrangements of battery cells. See, this positive terminal of a first battery is connected with the negative terminal of the second battery. and this positive terminal of the second battery is connected with the negative terminal of the third battery, and this positive terminal of the third battery is connected with the negative terminal of the fourth battery, but the negative terminal of the first battery is directly given in the circuit, and the positive terminal of the fourth battery is also directly given in the circuit. This will conduct or produce or propagate current for total volts. Here they have given 1.5 volts per battery, that means 1.5 plus 1.5 plus 1.5 plus 1.5, so totally 6 volts. Now let me explain. Suppose n number of cells, okay, uncountable number of cells, each of EMF psi volts and internal resistance R ohms are connected in series with an external resistance R, as we saw in the previous internal resistance of a cell using voltmeter. The total EMF of the battery is equal to n psi because n number of cells. The total resistance in the circuit is equal to n into small r plus capital R. That means internal resistance is added by with the external resistance. By Ohm's law, the current in the circuit is I is equal to total EMF divided by total resistance. Total EMF divided by total resistance. We know the total EMF is equal to n into psi. Already we know this n number of cells, and the total resistance is equal to n small r plus capital R. First case, if small r, that means the internal resistance is very much less than capital R, then we get I is equal to n psi divided by capital R, or n into I1, where I1 is the current due to the single cell. Therefore I1 is equal to psi divided by R. Thus, if small r is negligible when compared to capital R, the current supplied by the battery is n times that supplied by a single cell. And in the case B, if small r is very much greater than capital R, then I is equal to n psi divided by n small r. If you take this n, you cut this both n, then psi divided by small r. Let's move to the cells in parallel. I think you can see this cells connected in parallel. See, the first positive terminal of the first cell, and the positive terminal of the second cell, and the positive terminal of the third cell, and the positive terminal of the fourth cell are totally connected to the circuit, and the first, second, third and fourth negative terminals have been connected all together. The total volt here we get is 1.5 volt. Okay, so altogether this 1.5, 1.5, 1.5 and 1.5 all form into one, which is 1.5 volt total. Let me explain. Let n cells be connected in parallel between the points A and B, and the resistance R is connected between the points A and B as shown in the figure. Let psi be the EMF and R be the internal resistance of each cell. Therefore, the equivalent internal resistance of the battery is 1 by R equivalent is equal to 1 by R plus 1 by R plus dash 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 till 1 by R into N terms. That means N by R. So, here R equivalent is also equal to R by N. Since it is a reciprocal, we put R equivalent equal to small r by N. And the total resistance in the circuit is capital R plus small r by N. As you know, the current in the circuit is given by I is equal to psi divided by small r by N plus R. Which is I is equal to N psi divided by R plus N capital R, and which in case 1, that means A, if R is very much greater than capital R, then I is equal to N psi divided by small r, or which is equal to N into I1. In the case 2, if small r is very much less than capital R, then I is equal to psi by R. Thank you students. See you in the next class.